Chicago, and we're trying to make the quantum prairie happen here in this region. So compute collective. Compute, we all love computers. So how many of you guys have actually used a quantum computer? Okay, so basically none of you. That's shameful, guys. This is Chicago. We have Governor Pritzker putting in lots of money into quantum computing, quantum information science. We have federal funding coming in. It's going to be big here, and we got to have great people and great engineers that are going to do computing. So Compute Collective, let's pull out our computers and let's take a minute to use qBraid today to run your first quantum computing circuit on a SV1 simulator. Does that sound all right with you guys? All right. So how many of you guys have actually brought your computer? All right, so let's pull them out. Let's go. Let's get them out. You can also do this on your phone. Expect that parts of the screen might be a little too large. Go. All right, so qBraid, we essentially offer a one-stop platform for the quantum ecosystem. Your quantum hardware, your quantum software is available at the tip of your fingers. So what does that exactly mean? We have our fireside chat with Google. So I'm sure maybe you've heard of Cirq. It's their quantum Python framework that's open source, as well as OpenFermion if you're on the chemistry side. Those two packages sometimes just don't work well together. If you're a developer, you know about the dependencies, Conda environments, installing Proof on a new computer, and then being like, why is Conda not working for me today? That is what we call, in our industry, classical setup. What we aim to do is just skip all the classical stuff and focus on the quantum stuff, because we are a quantum computing company. We enable those who are working with quantum computers a smoother, better experience using our platform. So if you are interested in joining in this workshop, go to account.qbraid.com, create an account. I'll wait a little bit. And then we have a special code for you guys to get a little bit of credits and some access. It's called EHNU6626. If you guys know what this actually means, that's pretty cool. But I expect not. So it's OK. All right. So there are a lot of quantum computers out there and a lot of modalities. So you may have heard of like superconducting quantum computers, perhaps neutral atom computers, trapped ion computers, as well as silicon dot quantum computers and whatnot. All these modalities can be gate-based, which means that they essentially take in what you guys may be familiar as FPGA-like circuits and can run them on their quantum computers and perform operations on what we call qubits, which are quantum bits. OK. So you should be greeted by something like this. This is our platform, and you can go to the Manage page and just enter in your access key as you saw here. So who's gotten there? Who? Raise your hand if you've gotten this point. Great. OK, sweet. All right. So then what you're going to do is click on the Launch Lab button. What this Launch Lab does is it's going to take you to your Jupyter Lab instance. So what you see is you're going to be taken to what looks very familiar to you if you are from the AI space. So lab.qbraid.com is basically a Jupyter Lab instance that's available for you to run and basically access quantum computers without any of the cloud setup. OK. OK, internet take a little while, but that's OK. On the right-hand side of my panel here, you see this ENVS. This is our basically Python environments that we've curated to have you access various quantum computing software. On top of that, some of these already have quantum jobs or quantum hardware access already built in. So today, all I'm going to do is use the Amazon Broadcat one, which you can install for yourself as well, as long as you've added the code. And you can also choose from a variety of other environments here, from PyTorch to, for example, TensorFlow as well. Personally, I've used TensorFlow Quantum as well as across, and sometimes had to figure out Okay, I'm using this on a GPU. Okay, what does this mean when you need to configure these things? We also make sure that this environment is well configured so then you don't have tricky installations, particularly for GPUs as well. So if you are interested in that, that's also something we offer. Okay. So one more thing I want to show you guys is on the next page of our slides, we have kind of like a screenshot of what it looks like, and then we have this QR code. This QR code essentially launches our open source demos from GitHub into your lab. What you can also do is just go to the qBraid lab demo GitHub. Did you get the photo? Okay, you want to get the photo again? Okay. Great, so if you create an account, this will launch this open source repository into your Jupyter instance. And if you also want to take a look at it from the GitHub side, maybe you're on a computer and you want to just type it in, here it is. And we're going to essentially walk through ourselves one of the most famous quantum computing experiments, which is the Bell test that was performed and by, well, it was performed by Anton Zeilinger, John Clauser, as well as Alan Maspect, and won a Nobel Physics Prize very recently. And we'll be walking through that notebook together. Okay, everyone good here? Okay. So I'm going to click on that as well. All right. So my GitHub repo should have been cloned into my account. And we'll get started with basically running your first quantum circuit. Don't you wish you brought your computer today? Please, this is pretty cool stuff. You don't get to use a quantum computer any time of the day. But we're hoping that once you've created this account, we have tutorials set up, and you won't have to deal with the Python dependency issues. So there's no excuse that it's not going to work. These notebooks are available for you to run, and you should be able to essentially get started on them as well. All right. Just refresh. OK. So let me pull it up. Aha. All right, so we're going to go to qBraid lab, and then we're going to run quantum jobs. And we're going to pick this notebook here. And what we're going to do is make sure that you've installed the Brocat environment. So you make sure to select your Brocat environment, and then activate the kernel here. And then you also need to make sure that it's also selected. This is like a minus error that we see often that people make. Make sure that your kernel is also selected, not just your environment. We do this a lot at hackathons. We've done this at MIT. We've done it at Yale, Stanford. Everyone still makes these mistakes. I wish we could do this thing. Yeah.
Can you just show where you selected that again?
Yeah. Yeah. So we have our Python environments set up here. Think of these as your conda environments. I can even show you that we can interface with them with our Suite CLI, which we use Typer for to develop. And then we also have the kernel that you're going to have to set up here and make sure that it's running. So every Jupyter notebook needs a kernel for it to execute the cells. But then there's also just a separate conda environment, basically a Python environment for you to do other things with like the CLI one. OK. Let's see. OK, not sure why that's not working, but that's OK. So we have bits and cells of our CLI here. So you can just kind of walk yourself through. You may have a lot less environments than I do. And then we also can get you your credits as well. You can actually enable quantum jobs. If you don't like a Jupyter environment for yourself and you're like, oh, this is for scientists, I'm a programmer, you can look into our demo repo as well. And you'll find that we have an SDK as well that's more for those who are interested in developing locally with their VS Code or whatnot. We will have VS Code as a browser someday once we get around to it. OK. So what we're going to do is run a Bell circuit. This circuit essentially produces an entanglement, which is one of the key things that is very quantum and is not able to be done classically. And this quantum circuit was used in particular to demonstrate that there are that hidden local variables were not the cause of essentially some of these quantum phenomena. This is a big deal. That literally means that quantum mechanics is like a real thing and not something that Einstein thought was shouldn't exist. So this is actually proves Einstein wrong and actually was part of the most important milestones in quantum mechanics and quantum computing as well. All right. So right here, you guys might be familiar with ARNs. How many of you guys are familiar with ARNs? Who's got an AWS cloud on their backend? No? OK. Mostly maybe GCP. We're a GCP. OK. So what you've got here is essentially just like a code that allows you to select a quantum computer that's available. So right now, what we're going to do is use a simulator. Depending on availability, you have all these computers here for you to explore. This is Aquila, which is a neutral atom quantum computer, started by the startup qEra. Highly recommend them. As well as IonQ. You may have heard them. They're also one of the few companies that have IPO'd in the quantum space. And very recently, we have a 20-qubit superconducting device by the international, I think it's called IQM. And it's a 20-qubit quantum computer with a 99.51% 2-qubit gate fidelity, which is high for a superconducting device. So you can select your relevant ARNs here and then just copy it in. Just run this cell. And basically, that's it. You've now successfully ran a Bell circuit on a simulator, or if you swap out that string right there, a quantum computer. So that's as easy as it gets. Pretty maybe underwhelming, but if you actually had to go through this, as many of our customers have done before, the pain point is that you have to go talk to your cloud people, and then you have to go be like, well, what is this quantum computing thing? I don't know why we have to have this service, set up all this IAM. And at the end of the day, these are also researchers. Quantum computing is very early. So they're not very well versed in the coding part, which is where we need you guys as well. So once you've got your cell executed, you should see your job as well show up here. And then you'll be able to get your jobs, get your results, and also retrieve your results here as well. Any questions so far? Has that been 15 minutes? I'm not entirely sure. I can go into our SDK as well. OK. Sure. OK. So who's gotten to this part? Anyone gotten to this part? Yes? No? Maybe? Was it too fast? It's okay. OK. All right. Well, if you attend any of these hackathons, they're open source. They're available anywhere. You probably will run into qBraid, and maybe you'll get it done a little faster next time. But this is great. So I'm glad that some of us are now able to have a wealth of resources here. I can maybe talk a little bit more that's a little quicker than our SDK. We have docs here. So if you are like, oh, what does AWS offer? What does qEra offer in terms of what they have in their software? We have all of these here. And you can check your quantum jobs. And we also have variable compute. This instance does not, but we also have variable compute for you, as well as GPUs and GH200s all the way down to, I think, Ks as well. So yeah. Up and coming features we have, I guess I can mention really quickly, is we have real-time collaboration coming through, as well as, of course, AI features for making sure that you can code a lot faster than just typing on your own. So yeah. Any questions?
This is amazing.
Yeah.
How is this right now? Is it like education or academics? Or is it more in application? And then where do you see?
Great question. So I think very recently, the head of quantum computing at IBM has been just shouting to recommending our product because they sunsetted their own version of this quantum lab. So we've seen an inundated demand from all these universities across the world who are like, oh, we need this. And they just recently did their Qiskit Qiskit Quantum Challenge, which is like this IBM challenge where thousands of people across the world are hacking on quantum computing challenges that they provided. And qBraid was one of those solutions that is out there and got people from start to finish. You'd be surprised how many of these people on Discord are like, I don't even know why my Python environment's not working. So this is kind of where we're seeing a lot of the demand. But as the community grows, what we're also seeing is those people who were grad students are now moving into enterprise. And while these teams are very small right now, mostly writing papers, eventually, and we've seen great progress on the hardware side, in particular from QEra and their Harvard lab, from Michel Lueken's lab, as well as from the likes of course, Google, and some exciting news from AWS as well about their cat qubits. As long as this hardware progress continues and this thoughtful as well as this strong progress, we expect that enterprises will be like, OK, what exactly will be like our compute solutions will be where we need to like add in a quantum computer in a way that we didn't even like know right now. And that's where we're getting people started, having these demos. We even have white label versions from quantum computing companies that are like, we need this front end for ourselves. And that's kind of where we're at right now. And hopefully we get to the point where maybe we're like NVIDIA and we just have a bunch of computers running everywhere. But long way down the road. Yeah. Yes. Correct. Yeah, so that's a great question. So you actually need to understand like error mitigation software. So there's, I'm just going to point out Matik, which is a error mitigation software provided by the Unitary Fund. And this is actually one way of installing it and just getting it ready for yourself. So if you want to know like zero noise extrapolation, or you want to experiment with a quantum computer and connect it using Matik, essentially your integrations are all here for you, and it's available for you. So that's actually how we enable some of these scientists to do their work. And we've had people also do various codes as well, so error correcting codes, experiments, and we have some startups that are working on that using our platform. Yes?
Carry on meeting, and Ricky will get on here. So
sure. Cool. Yep, thank you guys.